Okay, all I want to do here is to add some names and notation to the kinds of things we've been doing. So remember, when we looked at stuff from yesterday, we had a graph that looked like this, and we started drawing rectangles, etc., etc., etc. When you add the areas of sums of rectangles, what you get is something called a Riemann sum. Now that's just going to be the sum of areas of rectangles. We'll give the formula in a second. But Riemann is usually listed as one of the top 5 or 10 mathematicians of all time. The greatest unsolved problem in mathematics right now is named after him. It's kind of sad that when people walk out of calculus and we say Riemann, it's like, oh, it's the sums of areas of rectangles guy. But apparently he was really, really nice. He was really, really bright, and he died at like 39. Anyways, when we're adding areas of rectangles, we call the sum of the areas a Riemann sum. Now, we had 2 different kinds of sums yesterday. What we'll try to do is just add the notation that goes along with this every time. So I'm going to have to try to give myself lots of space, like this. Now, you always have a starting point, and usually you call that starting point A. You always have an ending point. You always call that ending point B. Now, you usually chop this up in little pieces. I'll call that a subdivision or a partition. You're just breaking it up in little tiny pieces. Usually when they use this notation, they'll call this axis T. That fits with what we did yesterday. Now, usually what you do is you chop it up into n pieces. So n is always going to be the number of rectangles. Now, each of these is a value of t, but they're different. And so what happens is we give them names. We always call the very first one t0. We call the second one t1. We call the third one t2, etc. And when you get to the very, very last one, that's tn. So A is always t0, B is always tn, and each one of these has a name. Now, there's 2 kinds of rectangles we did yesterday. We were doing upper sums and lower sums, but in general, if you're trying to program these things, you don't try to do upper sums and lower sums. You try to do left sums and right sums. Let's talk about left sums just for a minute and try to write down something. I'm going to write down left. The number of rectangles is always important, so they're going to call it left n. And what do I do for left n? Well, what I need to do is put a rectangle on each one of these little bottoms. So what I'm going to do is I'm going to draw a side. I'm sure you can do a better job than I'm going to do here. There's a side. There's a side. And I need to figure out where to put the top. In that first little interval, what I want to do if I'm doing left n is go to the left end point, and from the left end point go up to the graph, and at that height draw the top. Ta-da! And we've drawn our first rectangle for left n. Now, if I want to do the second one, I'm going to go to the second interval. I go to the left end point. From the left end point, I go up to the graph. I like to draw the sides first. You can do what you want. And so in that second interval, I go up to the left end point, I go up to the graph, and I go like this. And you can see so on and so on and so on. Now, it's not true that left end is always bigger. If the graph is always going down, and I keep using left end points, I'm always going to be drawing rectangles that are bigger than the graph. Now, what we started doing yesterday is we started writing down the areas of these things. Well, let's see here. Each one of these has a little width. They usually call the width delta t. So I'm going to call my first width delta t. How do I get the height of my first dot? Well, we have to have a formula. Here in this section, we always call the formula r of t. So I need to take that first value of t, that's t0, and I plug in r of t, and I get r of t0. And this is going to be my first height times my first width. That's the area of my first rectangle. The area of my second rectangle would be r of t1 times delta t, and so on, and so on, and so on, until you get to the very last one. Now, what's the very last one? Well, it has a width. So So write down delta t. It's r of something. I just have to be a little bit careful here. You notice that the first rectangle had a 0 in it. The second rectangle had a 1 in it. Right? When I get to the nth rectangle, I'm not going to have an n, I'm going to have an n minus 1. I'm going to put a little n minus 1 right here. And we have all the notation we need for the left Riemann sum. Yeah, and that's how the picture goes. The right Riemann sum isn't much different. I don't want to do too much erasing here. I'll try to use different colors if I want to do the right Riemann sum. I'm hoping pink shows up. I want to do the right Riemann sum. Now, how does this vary? If I want to do the right Riemann sum, I go to the first interval, but instead of using the left endpoint, I use the right endpoint. So I go to the right endpoint of my first interval. My right endpoint, I go up to the graph. If I draw the side here, I'll get like this. If I use that dot to draw the top, I'll get like this. And I'll try to draw the shading just a little bit different. So you can see the pink shading is for the first rectangle of right n. The second rectangle will look like this. The third rectangle will look like this. And this also has notation. Here we go. I want the area of that first rectangle. Well, the width of the first rectangle is delta t. That hasn't changed. What has changed is which point I plugged in. I'm not plugging in t0 to get that height anymore. I'm plugging in t1. So I'm going to get r of t1. The next one is going to be r of t2. And so on, and so on, and so on. I guess those are officially the yada 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 dots. When I get to the very last one for right is going to look just like that. And you can see I actually used that last dot to plug in. So my last dot, I use that last dot to plug into the function. I get r of tn. I multiply by the width. And I get the right Riemann sum. Remember, that's just the sum of areas of rectangles. Now, if we go to our book, I'm going to stop right here, or I'm going to go to my book in just a second.